So in this video, we are going to find the Laplace transform of some functions using this table as our guide. So I have derived the formulas for all these functions in my previous videos. So we are going to use this table as our guide to solve Laplace transforms. But before we go into that, we have to learn this important property of the Laplace transform, which is called the linearity property of the Laplace transform. That is, if you have the Laplace transform of a function, let's say a times f of t plus b times g of t plus c times h of t, right? This one is equal to what? So this one is equal to the integral from 0 to infinity of e to the negative st multiplied by the function we are seeking to transform, which is a times f of t plus b times g of t plus c times h of t, all this one and then dt. All right, cool. So that means that this one, you can split this one into three different integrals. We have the integral from 0 to infinity of e to the negative st multiplied by a times f of t dt, plus the integral from 0 to infinity of b times g of t, to infinity of e to the negative st multiplied by b times the g of t dt, plus the integral from 0 to infinity of e to the negative st multiplied by c times h of t dt. Alright, cool. So this a is a constant in the t world, so I'm going to bring it out here. Then I have the integral from 0 to infinity of e to the negative st times f of t dt. This one is a constant, that's b in the t world, so b, the integral from 0 to infinity of e to the negative st multiplied by g of t dt. Cool. And then the last one is going to be, this c is a constant, it comes out in front here, so plus c, the integral from 0 to infinity of e to the negative st multiplied by h of t dt. So this one is equal to what? So this one is c, I beg your pardon, so this is c. So that means that the Laplace transform of a multiplied by f of t plus b multiplied by g of t plus c multiplied by h of t, this one is equal to, so we have a, the first one here, and this one is the Laplace transform of the function f of t, so that is a times the Laplace transform of f of t. And now plus, this is b, this is the Laplace transform of g of t, so this is the Laplace transform of g of t, plus c, this is the Laplace transform of h of t, which is what we have here. So this one can be written as a, the Laplace transform of f of t can be written as capital F of s, plus b, the Laplace transform of this one can be written as g of s, plus c, the Laplace transform of that can be written as h of s. And this one is equal to the Laplace transform of a times f of t plus b times g of t plus c times h of t, like this. So that means that the property of the Laplace transform, so the Laplace transform of a linear combination of functions is just equal to distributing in the Laplace transform operator. So that is what we have, and we are going to use this one to solve our functions, the Laplace transform of 10 functions that I'll be solving in this video. So let's start with the first one, why not? So the first one, let me do it in yellow. So this is number 1. We are going to find a Laplace transform of 2t to the third plus 4t squared minus 6t plus 2. So using the property, we are going to have the Laplace transform of 2. So this one is going to be 2 times the Laplace transform of t to the third plus 4 times the Laplace transform of t to the second minus 6 times the Laplace transform of t plus the Laplace transform of 2. So this one is equal to, so now Laplace transform of t to the third, we are using this one, right? So t to the n is n factorial divided by s to the n plus 1. So in this case, n here is equal to 3. So this is going to be 2 times, the Laplace transform of this one is going to be 3 factorial divided by s raised to the power 3 plus 1 plus 4. The Laplace transform of t squared, that is going to be 2 factorial divided by s raised to the power 2 plus 1 minus 6. The Laplace transform of t to the power 1, that is going to be 1 factorial divided by s to the power 1 plus 1 plus this one is the Laplace transform of 2. So that one can be written as 2 times the Laplace transform of 1, which is the same as 2 times the Laplace transform of 1 is 1 over s, if we can go back to our table. So this is 2 times the Laplace transform of 1, which is 2 times 1 over s. Cool, so this one is going to be 2 times 3 factorial is 6 and 2 times 6 is 12. So this is 12 divided by s raised to the power 4. Plus this is 4 times 2, which is 8 divided by s raised to the power 3 minus 1 factorial is 1 times 6, which is 6 divided by s squared, and now plus 2 over s. And this one is the Laplace transform of 2t to the third plus 4t squared minus 6t plus 2. So let me put this one in a box, why not? So let me switch colors and then we look at the second one. So let me do it in blue. Okay, cool. So 2, we have to find the Laplace transform of 4e to the 2t minus 3e to the negative 2t. So now using the linearity property of the Laplace transform, this one is going to be 4 times the Laplace transform of e to the 2t minus 3 times the Laplace transform of e to the negative 2t. Let's go back to our table. Our table, the Laplace transform of e to the at is the same as 1 over s minus a. So this is what we have. So this is equal to 4 times the Laplace transform of this one is 1 all over s minus, what is a in this case? A in this case is positive 2. So that is 1 over s minus 2 minus 3 times the Laplace transform of this one is 1 all over s minus, what is a in this case? A in this case is negative 2. So that is going to be s minus negative 2. So this one is equal to 4 divided by s minus 2 and now minus 3 divided by s plus 2, that is negative negative. And this one is the Laplace transform of 4t squared, 4e to the 2t minus 3e to the negative 2t, like this. You can put that in a box. Cool. Now the third one that we are going to look at is, so I'm going to do this one in a different color, so let me call it this color is going to be pink. And now we are going to have the Laplace transform of sine of 3t minus 2 times the cosine of t. Correct. So linearity property of the Laplace transform, this one is the Laplace transform of sine of 3t minus 2 times the Laplace transform of the cosine of t. Cool. So what is the Laplace transform of sine of t? So we have the Laplace transform of the sine of at, and this is equal to a divided by s squared plus a squared. Alright, so let's go down there. So this one is equal to, this one a here is equal to 3. So that is going to be 3 divided by s squared plus 3 squared minus 2 times the Laplace transform of the cosine of t. Cosine of at is s divided by s squared plus a squared. So here s divided by s squared plus a squared. A in this case is 1 because this is 1t, right? So 1 squared. So now simplifying this one is going to be 3 divided by s squared plus 3 squared is 9 minus 2 times s is 2s divided by s squared plus 1 squared is 1. And this one is the Laplace transform of the sine of 3t minus 2 times the cosine of t. Alright, cool. So this is what we have for the third one. For the fourth one, I am going to switch colors again. So the fourth one is going to be, we are going to find the Laplace transform of this function. That is 3 times the sine hyperbolic of 2t plus 2 times the cosine hyperbolic of 3t. This is what we are going to find. So the Laplace transform of this function using the linearity property again, that is going to be 3 times the Laplace transform of the sine hyperbolic of 2t plus 2 times the Laplace transform of the cosine hyperbolic of 3t, like this. So now let's go to our table again. So the sine hyperbolic of at is going to be equal to a divided by s squared minus a squared. So this one is equal to 3 multiplied by, this is a here is 2, that is a in this case is 2 divided by s squared minus a squared, which is 2 squared, plus 2 times the cosine hyperbolic, Laplace transform of the cosine hyperbolic of 3t. Cosine hyperbolic of at is s divided by s squared minus a squared. And this one is going to be s divided by s squared minus a squared. A in this case is 3. So this is going to be 3 squared. Cool. So this one is going to be 3 times 2 is 6 divided by s squared minus 4 plus 2 times s is 2s divided by s squared minus 3 squared is 9. And this one is the answer to our problem. And this is the Laplace transform of 3 times the sine hyperbolic of 2t plus 2 times the cosine hyperbolic of 3t, like this. Alright, cool. So I forgot to box this answer, so let me put this one in a box and then we proceed. Okay, now this is the fourth one. Now the fifth one, we are going to find the Laplace transform. So I'm going to do this one in red. You are going to find the Laplace transform of this function, that is e to the 2t multiplied by sine of t plus e to the t multiplied by the cosine of 2t, like this. So using the linearity property, this is the Laplace transform of e to the 2t multiplied by sine of t, right? And now plus the Laplace transform of e to the t multiplied by cosine of 2t, like this. Cool stuff. So now what is e to the t multiplied by sine of t? What is the Laplace transform of that? Here we are multiplying an exponential function e to the bt and then multiplying that one by the function f of t. So the Laplace transform is the Laplace transform of this function f of t, but the s variable or the complex variable is shifted by the constant in the exponential function. So this one is going to be f of s minus b. So that means we just have to find the Laplace transform of this and we shift the s variable by b, the constant b. So now let's go down there and finish up with this one. So this one is going to be, we are going to find the Laplace transform of sine of t. And sine of t is going to be 1, that is sine of 1t, 1 all over s squared plus 1 squared, which is 1. Right, and we are going to evaluate this one by shifting the s variable by 2. So s here is going to be replaced with s minus b here is 2. That is our b here, that is 2, right? Plus the Laplace transform of this, we just have to find the Laplace transform of the cosine of 2t, and that is s divided by s squared plus a squared. A here is 2, so 2 squared is going to be 4. And we are going to evaluate this one at s to be equal to s minus 1. B here is equal to 1, that is 1t. So now this one is going to simplify to what? So that means that in place of s, I'm going to replace it with s minus 2. So we have 1 all over s minus 2 all squared plus 1. Plus here replace s with s minus 1, that is going to be s minus 1 divided by s minus 1 all squared plus 4. And this one is the Laplace transform of this function. The Laplace transform of e to the 2t multiplied by sine of t plus e to the t multiplied by cosine of 2t. Cool. Now we are done with question 5. We have to go to question 6. So question 6 permits me to do this one in blue. Why not? So question 6, we have the Laplace transform of e to the negative 4t. right? And this is multiplied by t squared. That is the same thing. So here we have to use this property. That's a shifting property of the Laplace transform. So here e to the bt multiplied by f of t. We just have to find the Laplace transform of the function f of t, and then we shift the s variable by the constant b. So that's what we are going to do here for question 6. So this one is going to be, I'm going to find the Laplace transform of t squared, which is 2 factorial divided by s raised to the power 2 plus 1. And then I am going to evaluate s at what? S is going to be equal to s minus negative 4. That means we are shifting the s variable by negative 4. So s minus negative 4. So this one is going to be 2 factorial is 2 divided by s raised to the power 3, evaluated at s to be equal to s plus 4. That is negative negative. And this is equal to 2 divided by s plus 4, this one raised to the power 3. This one is the Laplace transform of e to the negative 4t multiplied by t squared. Simple. So now let's go to the 7th one. The 7th one is this. So we have the Laplace transform of this function, that is cosine square of t. So this one is equal to what really? How do you find the Laplace transform of the cosine square of t? We can find the Laplace transform of the cosine of t. What about cosine square of t? Now let's do some basic trigonometry. So cosine square of t from the double angle identity can be written as 1/2 into 1 plus the cosine of 2t. Right? So this is what we have for the cosine of cosine square of t. And this one is going to be 1/2 using the linearity property of the Laplace transform. We have the 1/2, the Laplace transform of 1 plus 1/2 times the Laplace transform of the cosine of 2t. So this one is equals to 1/2 times Laplace transform of 1 is 1 over s. That is the first one in our table, plus 1 over 2. The Laplace transform of the cosine of 2t is going to be, Laplace transform of the cosine of at is s all over s squared plus a squared. So this is going to be s divided by s squared plus a, in this case is 2. So that is going to be 2 squared. And this one evaluates to 1 over 2 times 1 over s plus 1 over 2 times s divided by s squared plus 2 squared is 4. So in the end, we are going to have 1/2 out, then 1 over s plus s divided by s squared plus 4. And this one is the Laplace transform of the cosine square of t. Alright, cool. So this is the 7th one. Now the 8th one, we are going to find the Laplace transform of this function. So the number 8 is going to be the Laplace transform of sine to the 4th power of t minus cosine to the 4th power of t. Cool. So we have to evaluate what this is before we take the Laplace transform, because we can't find the Laplace transform of sine to the 4th power of t. So I'm going to work that one out. So if I have sine to the 4th power of t minus cosine to the 4th power of t, this one can be written as sine to the 2nd power of t minus cosine to the 2nd power of t. And this is multiplied by sine to the 2nd power of t plus cosine to the 2nd power of t. Right? When we multiply these guys by foiling, we are going to get the left hand side. So this one is equal to, this one from the Pythagorean identities is equals to 1. But this one, I'm going to reverse this one as the negative into cosine square of t minus sine square of t. And this is multiplied by 1. This one is 1 from the Pythagorean identities. And from the double angle identity, we know that cosine square of t minus sine square of t is the same as cosine of 2t. And this is multiplied by 1 with negative in front. So implying that sine to the 4th power of t minus cosine to the 4th power of t, this is going to be negative cosine of 2t. Cool. So it means instead of taking the Laplace transform of this one, I am going to take the Laplace transform of negative cosine of 2t, like this, right? And this one is equals to negative out the Laplace transform of the cosine of 2t. So that means that we are going to have negative into Laplace transform of the cosine of 2t is what? Laplace transform of the cosine of at is s divided by s squared plus a squared. So this one is going to be s divided by s squared plus a squared. A in this case is 2, so that's 2 squared. So we are going to get negative s divided by s squared plus 2 squared is 4. So that means that the Laplace transform of the sine to the 4th power of t minus cosine to the 4th power of t, this one is equal to negative s divided by s squared plus 4. Let's put that in the box. Okay, so now we are going to the ninth one. So the ninth one, I'm going to do it in yellow. Alright, so question 9, we are going to find the Laplace transform of t multiplied by e to the negative t, and this is multiplied by cosine of 2t, like this. So we are going back to our table. So our table here, we are going to use this formula, this expression here. So if you have t multiplying a function f of t, that means that you have to, in order to take the Laplace transform, that is going to be the derivative with respect to the power of the polynomial t. Then you differentiate to the nth power of the Laplace transform of the function f of t. So that means we have to find a Laplace transform of this one, and then we differentiate that n different times. So that is the same as our question 9. If we go down there, so question 9, that means we have to find a Laplace transform of this one, and then we will be able to take the first derivative, because this one is t raised to the power 1. So let me write it again here just to refresh our memory. So the Laplace transform of t to the nth power multiplied by the function f of t, this is going to be negative 1 raised to the power n, and then the nth derivative with respect to s of the Laplace transform of f of t. So now let's find the Laplace transform of this, and then we differentiate it only one time, because this is t raised to the power 1. Right, so Laplace transform of this one. So what I'm going to do, I'm going to have the Laplace transform of t e to the negative t times cosine of 2t. This one is going to be equal to, I'm going to differentiate it one time. So this one is going to be negative 1 raised to the power 1, because n here is 1. And then I am going to differentiate it only one time, that is this. And then we are now going to find the Laplace transform of the function f of t, which is this one. So that is going to be, so finding the Laplace transform of this one, I have to find the Laplace transform of the cosine of 2t and then shift it by negative 1. Right, so this one is going to be Laplace transform of the cosine of 2t is going to be s divided by s squared plus 2 squared. And this one, we are going to evaluate this one at s to be equal to s minus negative 1. We are shifting the s variable by negative 1. Right, so this is what we have. So this is equal to negative 1 raised to the power 1 is negative 1, which is negative the derivative with respect to s of, now we have s divided by s squared plus 2 squared is 4, and we are going to evaluate this as s to be equal to s plus 1, that is negative negative here. So you have this negative d ds of this one is now s plus 1 divided by s plus 1 all squared plus 4. So this one is the Laplace transform of this function, and it is multiplied by t, so it means we have to differentiate it only one times. Alright, so this one is going to be negative into, now let's differentiate this using the quotient rule. So this one, you have s plus 1 all squared plus 4, all this one is squared, right? And the numerator is going to be, we are going to keep s plus 1 all squared plus 4. We are going to keep this one constant, and we differentiate the numerator with respect to s, which is 1, minus, we are going to keep s plus 1 constant, and then we differentiate this one with respect to s, and doing that is going to be 2 times s plus 1, like this. So now let's simplify the numerator. So this is negative into, so the numerator is going to be s plus 1 all squared plus 4, right? And this one is going to be minus 2 times s plus 1 all squared. All this one divided by s plus 1 all squared plus 4, and all this one is squared. So we have negative into, this is 4. Now this and this, when we combine them, that is going to be negative s plus 1 all squared divided by s plus 1 all squared plus 4, and all this one is squared. And now we can reverse it with a negative in front, and that is going to be s plus 1 all squared minus 4 divided by s plus 1 all squared plus 4, and all this one is squared. And this one is the Laplace transform of t multiplied by e to the negative t multiplied by cosine of 2t, like this. We are done. We can now put our answer in a box. Cool. So this one is the 9th one. So the Laplace transform of t multiplied by e to the negative t multiplied by cosine of 2t is this guy. Cool stuff. Now the last one, we are going to do this one in pink. So we have this. So the last one is question 10. We have to find the Laplace transform of t squared multiplied by sine hyperbolic of 3t. So this one is equal to what? So we are using the same formula here. So the Laplace transform of t to the nth power multiplied by a function, this one is going to be equal to negative 1 raised to the power n, and then the nth derivative with respect to s of the Laplace transform of the function f of t. So now n here is equal to 2 because this t is to the second power, right? So this t is to the second power, n is 2, and now we have to find a Laplace transform of this. So this one is going to be negative 1 raised to the power n. N here is 2, and then we are going to have d squared over ds squared. That is differentiating this one 2 times, because n here is 2, of the Laplace transform of the sine hyperbolic of 3t. Sine hyperbolic of 3t, the Laplace transform of that is going to be 3 divided by s squared minus 3 squared, like this. So now let's simplify this one. Negative 1 squared is positive 1, so we are differentiating this one 2 times. So that is going to be 3 divided by s squared minus 3 squared is 9. And this one is equal to what? So we are differentiating for the first time and then differentiating for the second time. And now for the second time, this is going to be 3 multiplied by s squared minus 9 raised to the power negative 1, like this. So now let's differentiate. So d ds of, now differentiating for the first time, that is going to be negative 3 s squared minus 9 raised to the power negative 2. And now chain rule, differentiate here and then multiply. That is going to be multiplied by 2s. So we can pull some constants out. Negative 3 times 2 is negative 6 in front here. Then dds of what? So dds of, now we have s multiplied by s squared minus 9 raised to the power negative 2. Now let's differentiate for the second time. That is negative 6. Now differentiating for the second time using the product rule. So I am going to keep s squared minus 9 raised to the power negative 2 constant and differentiate s, which is 1. Plus I'm going to keep s constant and differentiate this one. So that is going to be negative 2 into s squared minus 9 raised to the power negative 3. And chain rule, differentiating is going to give you 2s. So now let's simplify. So negative 6, right? So this one is 1 all over s squared minus 9, all this one squared. That is this guy. And now negative 2 times 2 is negative 4. S times s is s squared. So that is negative 4s squared on top divided by s squared minus 9. All this one raised to the power 3. And now what do we have? We can take the LCM, right? So the LCM here is s squared minus 9, all this one raised to the power of 3. So this divided by this, that is s squared minus 9 minus this divided by this is 1 times the top, that is going to be 4s squared. And this one is multiplied by negative 6 in front. So we have negative 6, and now I'm simplifying the numerator. That is going to be negative 3s squared minus 9 divided by s squared minus 9, all this one raised to the power of 3. And this is equals to negative will cancel, so that's 6 multiplied by 3s squared plus 9 divided by s squared minus 9, all this one raised to the power of 3. So that means that the Laplace transform of t squared multiplied by sine hyperbolic of 3t, this one is equal to 6 multiplied by 3s squared plus 9, all this one is divided by s squared minus 9, all this one raised to the power of 3. And we can put that in a box and then wrap up the video. So this is the Laplace transform of the last one, and that concludes this video. So these are the Laplace transforms of like 10 different functions using all the Laplace transform formulas that we derived in my previous videos. So if you find this video helpful, you give me a thumbs up and subscribe to my channel. And if you want me to help you with a question, you can leave them in the comment section and I'll do my best to respond to all of them. And if you really enjoy the video, subscribe to my channel and then join me in my next video as we continue deriving the Laplace transforms of unit step functions. I will see you in the next video. Bye bye.